Okay, I want to talk about circular motion, and this is also known as centripetal force. Or centripetal motion, really. Centripetal means center seeking. And that's good to keep in mind, because the force that we see is center seeking. And so imagine it like this. This might be the sun, this might be the earth. The earth is moving in a mostly circular path around the sun. And you got to ask yourself, where is the earth's gravitational pull directed? And in fact, it should be directly towards the sun. The sun has a pull towards the earth too. That's Newton's third law. And those forces are equal and opposite. But because the sun is really massive, it has a much smaller acceleration. The earth's acceleration is much bigger. And we're going to just focus on the earth right now. So if the force is towards the center of the circle, that tells you acceleration, the center of the circle, that tells you the acceleration is also towards the center of the circle because they are always pointed in the same direction. So the question becomes, what keeps this from falling into the sun? Because we have a force pulling us towards the sun, but yet we're not falling into the sun. And this really comes down to what we call a tangential velocity. So our velocity at this point is tangent to the curve and pointed in that direction. So it's tangent to the path. Meaning, if the sun were to totally disappear, the earth would just keep flying off in this direction forever and ever and ever. But what happens is, circular motion causes an acceleration. So even though the speed is constant, the direction of the vector for velocity is changing. And as long as your direction is changing, your velocity is changing, which means you have an acceleration, which means you must have a net force. So what this force is doing is not changing the speed necessarily, it is changing the direction of motion. So when the earth reaches a point over here, its velocity is now directed in that. So all that force has been used to change its velocity to a path in this direction. Down here,